Hello students, welcome back to Toppr Live Classes. This is Ravi and I am a subject matter expert of physics at toppr.com. So in today's lecture, which will be the third part of circular motion, we are going to cover first of all we will cover the radius of curvature. So first of all, let's jot down what we are going to cover in today's lecture. So first of all we will cover the radius of curvature, and after we will cover the relative angular velocity. In many of the exams, generally questions are asked from this topic. We are supposed to find the relative angular velocity, and after that we will, by covering these two part, we will be almost done with the kinematics part of circular motion, and after that we will start the dynamics part of circular motion. So in that, first of all we will start with basic introduction of centripetal force and centrifugal force and their application, and we will also solve many problems based on this concept. And after that we will also see some concepts of circular motion in we will apply some concepts of circular motion in simple and conical pendulum. And after that we will also see the circular turnings of road, so which we also call as banking of roads, turnings of roads. So, and we will also solve many problems based on this, and most of these topics we will be covering under the dynamics part of circular motion. So let's begin with the radius of curvature. So radius of curvature. In radius of curvature, basically we are given, suppose some general curve will be given to you. For example, this curve, or might be any curve like this. So we can consider this curve as a combination of various infinite number of circular segments. For example, if you will consider this particular segment, let's consider this particular segment. So this is, we can call this as a circular arc, right? This is our circular arc. So if this is a circular arc, then it must be a part of some circle. Yeah, definitely यदि ये एक circular arc है तो ये कोई circle का ये एक part हो रहा ही होगा. Suppose we draw some circle like this. So this circular arc is a part of this circle. So we have to find the radius of curvature, that is radius of this circular segment. So we have to find this radius. So first of all, let's define what is the center of curvature and radius of curvature. Then the radius of that circle, radius of curvature is nothing but the radius of that circle which exactly fits at this arc length. So here the radius of curvature will be this one. The radius of this circle will be the radius of curvature, our in this case, and this center will be our center of curvature, right? So if these are the segments of circular arc, then we can also apply the concepts of circular motion here also, right? So let's try to solve some problems based on this radius of curvature, then you will more easily get the concept of radius of curvature. So we will cover this segment with one very important question. Suppose a projectile is projected with this velocity v0 at t equal to t0 from this point, right? And this is suppose h is our highest point. Now in this, and a mass of particle, let's say mass is m, given to us, and now we have to find the, so first of all let's recall before finding the radius of curvature, are you well aware with those concepts now, which I taught in the previous class, ki what is the tangential acceleration, radial acceleration, and what is the net acceleration, and those basics formulas, and the angular variables of the angular relation between those angular and linear variables. So here also we will use those concepts. So first of all, before finding radius of curvature, let's find what will be the tangential and radial acceleration will be at point O and point H. So first of all, find the tangential acceleration and normal acceleration at point O and H, and after that find the radius of curvature at point O and point H, and after that we have to find the radius of curvature at point O and point H. So first of all, let's find out the what will be the tangential as well as radial acceleration at these 2 points. So at point O, let's say at point O, it is also a part of circular segment. Then here also some circle will be there, and radius of that circle will known as our radius of curvature. So, and here also we have given some angle theta, it is projected at some angle theta. Now let's draw the FBD at this point at O. What will be the FBD of particle? Some mg will act as this, its velocity is at angle theta, and this is a circle, and we have to find the, first of all we have to find the tangential and normal acceleration. So here what we will have this as, this is angle theta, this will be our theta, right? This will be our theta. So here T is acting, G is acting in this way, right? G is here, and G cos theta will be acting here, and G sin theta will be in this way. So can you find, so now we can easily find ki at point O our tangential acceleration will be G sin theta, which is opposite to the direction of V naught. So here AT is minus G sin theta, and our AN, that is normal component of acceleration at point O, is G cos theta, right? And now here we have to find the radius of curvature. Radius of curvature, we know, we have seen this formula, AC equal to V square by R. So in this, by using this formula we can find the radius of curvature. Suppose AC is V square by R, so that implies R is equal to V square by AC. So this will be our radius, this R will give our radius of curvature, and this VC, and this V should be, for example, if there is some circle like this, it's V as V and some A is acting towards center, then radius of curvature will be given as V square by 1 AC. So here also in projectile, at point O also we can see what is the acceleration which is acting towards the center. It is G cos theta, and what is velocity at point A? It is V naught, right? So in our situation we have given key, here we have V naught, and along the center it is G cos theta, which is acting towards the center. Now we have to find the radius of curvature. So here radius of curvature will be V naught square by G cos theta. This will be our radius of curvature at point O. Now let's consider the point H, which is the highest point of projectile. So at point H, Let's draw some circle. Here this is point H, and as we know ki at highest point of projectile we have only the horizontal component of velocity. There is no vertical component of velocity at highest point. So velocity at highest point will be v naught cos theta, right? And we have to find the radius of curvature at highest point. First of all find the tangential and normal component at highest point. So at highest point there would not be any acceleration acting in horizontal direction, so AT will be 0 at point H, right? And what will be the acceleration acting towards the center at point H? It will be G, simply it will be G. So at highest point the acceleration which is acting towards the center is G. So at highest point our scene will become like this. We will have some v naught cos theta velocity speed, and G will be acting toward the center, and we have to find the radius of curvature at highest point. So at highest point our radius of curvature will become square of this velocity divided by the acceleration which is acting toward the center, and here it is G. So at highest point the radius of curvature will be by G. So in this way we solve the problems related to radius of curvature. And suppose in our problem if someone asks you to find the radius of curvature at some point, at general point when velocity makes an angle alpha with the horizontal, then how you will proceed? So in this case also we have to find the two things only. First one is the speed which is acting tangentially at this point, and second one the acceleration which is acting towards the center. So I'm leaving this one for you, so try to do it by yourself. I can give some hint to you ki at this point what will be the case ki horizontal component of velocity always remain constant in projectile motion, right? So at that point also we will have v naught cos theta, which was the horizontal component of velocity at time t equal to 0, will be equal to v cos alpha, which will be the horizontal component of velocity at that point when the velocity will be making angle alpha with the horizontal. So here we have got our v, and now we have to find the G, yani ki center acceleration which is acting towards the center at this point. So here also you can easily find ki here the G which will be acting towards the center will be, this is alpha, so alpha, so G cos alpha. Now you can find, right? So this was all about the radius of curvature. Now let's see the relative angular velocity. Relative angular velocity. First of all, what is angular velocity? Angular velocity, as we know ki angular velocity is nothing but the rate of change of angular displacement. But do you know one thing, this angular velocity also depends on the point of observation. It varies from point to point. For example, let's see this example. Suppose a particle is at point P and one observer is at center and another observer is at point A, let's say. So suppose some point is given. It is making angle theta 1 and this is making angle theta 2. So what will be the angular velocity of point P with respect to C? It will be d theta 1 equal d theta 1 by dt, right, with respect to C. And with respect to A, it will be d theta 2 upon dt. So here we can see key angular velocity also, it varies from point to point and it doesn't remain constant. So if can you find the relation between omega A and omega C? Here we can also find the relation between omega a and omega c. How? Let's see. Suppose this is the external angle, right? Theta 1 is in exterior angle property. We have learned this property, right? If some theta 1 is the exterior angle here, and theta 2, this one is the radius, this one is the radius, so angle will be theta 2 here also, right? So theta 1 is nothing but theta 2 plus theta 2, that is 2 theta 2. So d theta 1 by dt equal to 2 d theta 2 by dt, which is here we got the relation as this. D theta 1 by dt is omega c, and 2 into d theta 2 by dt omega. So here we see angular velocity at point C is twice of that we have at point O. So now let's come to our actual discussion, that is relative angular velocity. We have, now we know that angular velocity is nothing but the rate of change of angular displacement, but we can also define angular velocity as rate of change of position vector. Rate of change of position vector. Suppose this one is p and this p is moving in this direction, anything, so its position vector is r. So how this position vector is rotating, we can also define angular velocity as how this position vector is changing with respect to time. So in a similar way we define relative angular velocity. For example, we have to define the relative angular velocity of b with respect to a. Then we can say ki it's nothing but the rate of change of angular position vector of point b with respect to point a, right? Rate of change of position vector of a, of b with respect to a. So this was so now, so let's try one problem. For example, in exams, if we are asked to find the relative angular velocity of b with respect to a, then how we will tackle those problems. Let's see. Suppose there is point a, particle a, and another one is b, and it is moving like this v1, and it is moving like this v2, and we have to find the vb omega ba. We have to find. So how we will find this? First of all, resolve the component of velocity in two components, one in this way, in this theta 1 and this theta 2 is given. So here just resolve this velocity in two components, v cos theta 1 and another one as v1 sin theta 1, right? And in a similar way we have to just break this v2 into two components. One is along v2 cos theta 2 and one as v2 sin theta 2, right? Now we have to find the O, and then how we will find after that, how we will find the omega ba. So omega ba, we have to find omega ba. Then what we have to do, just we have to find vba perpendicular to this line. Suppose this separation is r, so this will be r, and this is the general formula we use to find the relative angular velocity of b with respect to a. So what we have to remember from here key, just we have to resolve the velocity in two components, one is along parallel and one perpendicular to the line joining them, and just find the relative velocity perpendicular to the line joining them, right? So here what will be the relative velocity along the line joining them? which perpendicular to the line joining them, perpendicular to the AB. So using this formula we can solve the problems. This is the general method. Let's see one problem here. Okay, suppose there is B and here is A, and A is moving in this way with velocity VA, and theta 1, it is making theta 1 with the line joining their centers, and VB is moving with along this direction with VB, right? So and here we have to find the omega BA. So we have to just follow these steps just as we have just learned. You resolve the components along the perpendicular to the line joining their centers, and second one along the line joining them. So here it will be VB cos theta 2, and here it will be VB sin theta 2. Here it will be V1, here it will be VA sin theta 1, and along this line it will be VA cos theta 1. But we have to consider only those components which are perpendicular to the line joining them, right? So here we will get perpendicular to the line joining them. So omega BA will be, what will be omega BA? It will be VA BA perpendicular to the line joining them and distance between them, that is R. So we can see keep VB minus, we have to find the VB. What will be VBA here? VBA here will be VB sin theta 2 minus, suppose we are taking this one as a positive y and this one as positive and this one as, then minus VA sin theta 1 VB sin theta 2 plus VA sin theta 1 by R. So in this way we can find the relative angular velocity. So this is the simple procedure which we have to follow in order to solve this kind of question, right? So I am leaving one question for you. You should attempt this question. Ki it's VA is moving along this line with angle theta A, and VB is moving along this line with angle theta 2, and here it is theta 1, and separation between them is R, and we have to find the omega BA. So now you can easily find ki how you just have to follow this simple procedure, right? Let's move to the, so this was about the kinematics part of circular motion. Are you seeing this question now? Omega BA. So this was all about the kinematics part of circular motion. So let's move on to the dynamics part of circular motion. So in dynamics part, basically we will cover the, first of all we will cover the basic introduction of centripetal and centrifugal force, and after that we will apply the concepts of circular motion in conical pendulum and simple pendulum, and after that we will see the turnings of rod. So first of all, let's see the centripetal force and centrifugal force. Centripetal and centrifugal force. So what is basically centripetal force? So we have already learned what is centripetal acceleration. That is acceleration which acts toward the center. So this is known as centripetal acceleration. So in a similar way we can define centripetal force as a force which acts toward the center. So suppose a particle is moving a circle, then some acceleration, or you can say there must be some force which which would be acting towards the center in order to do a circular motion. Otherwise we would not be able to do a circular motion in the absence of centripetal force, right? So centripetal force, so it's not a specific kind of force कि centripetal force ये एक specific kind of force, जैसे electrostat force हमने पढ़ा, gravitational force पढ़ा, magnetic force पढ़ा. So in centripetal force is not that kind of force. Any kind of force, that is कि these electrostat and magnetic force or gravitational force, these force can also act as a centripetal force, right? Even normal force or friction force, which we have already covered, can also act as a centripetal force, or their component might also act as a centripetal force. In later part, when we will solve some problems, we will see how the one component of normal or friction will act as a centripetal force, right? So in centripetal force, basically defined as mv square by r. And centrifugal force, so centrifugal force is in Newton's laws of motion we have learned some pseudo force, right, which we have to apply in non-inertial frame in order to apply the Newton's second law of motion. In a similar way here also, in circular motion also, centrifugal force is termed as a pseudo force, which we apply when we consider the motion of, so when we consider the circular motion from rotating frame, for example. So basically these two are not entirely two different force, but they come into existence when we change our frame of reference. So suppose, for example, let's say कि suppose कि there is some disk and which is rotating with omega, and here is some man, and here is some our observer 1. First of all, let's see our observer, what our observer 2 will observe when he will observe the motion from ground frame. This is our ground frame. So from ground frame what he will see कि he is doing circular motion, and if suppose there is some friction between this horizontal surface and this man, then what will be the force which will be providing? It's a centripetal force. So there would be some friction between that man and the disc, and that friction will be providing the centripetal force, due to which the man is moving in a circular path. So from ground frame what we will observe कि some force would be acting towards the center, and let's say here the friction is acting towards the center. So what is basically the purpose of friction? Friction generally oppose the relative motion between the two bodies. So here also, in order to oppose the relative motion between disc, suppose this horizontal surface and this man, friction will act towards the center. So here friction will act towards center, and this center acting force we will call it as centripetal force, and we will equate it as mr omega square. In general ground frame we generally do like this, or mv square by r. But what will happen if we will observe this motion from this point of view? When observer 1 will observe the motion of this, he will find कि this m1 is at rest, right? So but how it will be at rest? So there must be some force which is acting at this m1, which is keeping it at rest. So this force is nothing but the centrifugal force, which come into existence when we observe the motion from rotating frame or non-inertial frame. So here what he will do कि observer 1 will do कि for O1 m1 is at rest, so net force must be 0 for m1. So he will equate this as friction in mr omega square. And from here the name centrifugal come into existence. And one thing also key, what will be the tendency of this centrifugal force? Centrifugal force will try to throw you the radially outward. You have also felt some in this kind of centrifugal force during your in your practical life. Suppose during your suppose this here is a circular turn and one car is moving here. So what you feel ki is at circular turn, what we feel ki we felt like if we are being thrown away radially away from at circular part, right? So this is only because of centrifugal force. So centrifugal force is nothing but a pseudo force. It is not a real force, but centripetal force is a real force. So that is a basic distinction between centripetal and centrifugal force. So we will use the concept of centrifugal force when we will observe the motion from rotating frame, and otherwise we will observe our motion with centripetal force only. So let's do some problem based on this centripetal and centrifugal force. After that our concept will get more clear. So before starting any problem, let's see some basics behind this. Suppose I am giving you one case key in suppose AR is not 0 and AT also is not 0. Then what will happen in this case? AR is not 0 means some radial acceleration is acting on a body, and AT is also not 0 means it has both tangential as well as radial acceleration. In that case it will perform non-uniform circular motion, because some radial force is acting. So due to this it will move in a circular path, but AT is also not 0. So due to this it will also get some tangential acceleration also, and due to this it will have some unit in this direction and it will perform non-uniform circular motion. In second part, suppose AR is not 0 but AT is 0. AR is not 0 means ki body is moving in a circle, and AT is 0 means it has no AT is 0 means it is moving with constant speed, and AC means it is moving in a circular path. So it will here we have uniform, it will be a case of uniform circular motion. Now suppose we have a case the force will also case of linear motion, because AR is 0 then body is not performing any circular motion, and AT is 0 means body is moving with constant speed. But will this condition hold true for circular motion also? Yeah, it can also hold true, but at some particular instant of time. We will see it in conical when we will see simple pendulum, then we will see how this can also happen in circular motion also. So this was all about the basics of circular, centripetal and centrifugal force. Let's do some problem and we will see how we have to apply the concept of centripetal and centrifugal force in solving problems. So suppose it is a tension, here is a we have 2 kg block and 3 kg block are connected and it is moving with some omega. We have to find the, it is 2 meter radius length, it is 4 meter length. We have to find the tension here and here. What will be the tension? So what we have to just apply this concept key. First of all, let's draw the FBD of these. So what will be the FBD of 2 kg here? So suppose we are calling this as T1, here T2, and suppose we are observing our motion from here in rotating frame, and here it is T1. So what we have to do key, this will observe to be at rest if we will observe our motion from this point. So here we can easily observe, we can easily apply that T1 will be equal to m r omega square, right? And for this one 3 for 3 kg block, and for 2 kg block it will be T2 minus T1 will be equal to m r omega square, right? So in this way we can, now the rest is only the calculation. So here we have T1 is equal to m r is given 4 and omega is given 25, and T2 minus T1 is equal to 2 into 2 into 25. On solving we will get T1 and T2, right? Let's see at some more problems. Let's do one interesting question. Suppose that there is a string and here it is m, mass of block m kg, and suppose we have given this velocity v to this block. Now what will happen? It will perform some circular motion, and it is kept on a horizontal table, horizontal rough table, and here we have given it as a velocity v. So what will happen key, the tension in string will provide it as will act as a centripetal force, right? And here what about friction? Friction will act in this direction in this case. So basically we have to find the time t after which it will stop moving. It will stop moving. So here friction will act in this direction, because we have given v, then we have given v, so some tangential acceleration will act upon this as dv upon dt, and t will provide the centripetal acceleration to this block. So we have to integrate it from 0 to t when v will become 0, right? So minus mu gt 0 minus v, so v equal to mu gt, so this will give t equal to v upon mu g. After this much time it will be at rest, right? Suppose let's do one more problem, similar kind of problem, but here let's do one more similar kind of problem, but instead of tangential velocity, suppose there is some disk, and it is moving with constant omega. So we have to find the, and here we have some block B which has mass m. So we have to find the maximum omega for which there would not be any slipping, कि ओमेगा का वो मैक्सिमम वैल्यू बताइए जिसके लिए कोई स्लिपिंग ना हो दोनों के बीच. सो यहाँ पे देखेंगे, यहाँ पे क्या हो रहा होगा कि बॉडी रोटेट कर रही है इसके साथ. तो यहाँ पे आके हम लोग यदि आप मोशन को ऑब्जर्व करेंगे तो बॉडी की टेंडेंसी क्या होगी, द बॉडी विल हैव टेंडेंसी टू गेट थ्रोन अवे इन रेडियली आउटवर्ड डायरेक्शन. सो we have, first of all we have to find the omega for which slipping नहीं होनी चाहिए, जिसके लिए स्लिपिंग नहीं होनी चाहिए, slipping should not be there. So first what we have to do, we have to just draw the FBD at this point. So here so body has a natural tendency to get thrown away in radially outward direction. So what will be the direction of friction here? So here friction will act in a direction towards the center, so that ki body will be at rest and there would not be any slipping taking place. So m r omega square here will be get balanced by mu mg, right? So mu, when we will equate these two, mu mg will get m r omega square, m will get cancelled out, and omega will be equal to mu g by r. This will be the omega for which there would not be any slipping. After that slipping will take place. So this will be our omega max. Now there is one more similar kind of problem in which now instead of omega constant we have given some angular acceleration alpha. Then how we will apply that question in that case? Well, instead here omega was given as constant, but now I am saying at t equal to 0 omega is equal to 0 and we have given some angular acceleration with which the disk is rotating. Now in this case we have to find the time, find t after which slipping will take place. After which slipping will take place, right? So here what will be the scene कि यहाँ पे तो so here we are it has given constant angular acceleration. So in what will happen in this case कि body will have some tangential acceleration, it is equal to r alpha, right? And it will also have some centripetal acceleration as r omega square. So in this case friction, in which direction friction will act? The most important thing is we have to find the direction of friction, कि in which direction friction will act. So here we have seen कि friction is acting towards center, and how in this case the friction, we will decide the direction of friction. So here we can see कि, or here we can see कि body has both kind of tendency. Either it is accelerating in this direction also or in this direction also. So friction has to oppose that relative slipping. So basically friction will act here in the opposite direction of A net, right? So how we will find the friction here? So here m A net will be equal to mu n, that is mu mg, and m, and we know कि A net is, how A net is given as AT square plus AC square. So m will get cancelled out and AT square plus AC square will be mu g, and here AT is nothing but r square alpha square, and AC square is r omega square, and it is mu g square, right? So r square alpha square, we can write omega as alpha t, since omega naught is 0 given here. So omega, this is our t. From now here we can easily find the t, keep time after which block will start slipping. You can find t as, so r square alpha square plus r square alpha 4 t4 mu square g square, r square alpha 4 t4 equal to mu square g square minus r square alpha square, and t will be equal to mu square g square minus r square alpha square by r square alpha 4 1/4. This will be our t, right? Let's do one more important problem. Okay, suppose body cycle is moving with constant speed, suppose here. So we generally ask to find the normal at these 2 points. What will be the normal at point A and what will be the normal at point B? So how we will find the normal? So we just have to apply the concepts of circular motion here also. So just first of all draw the FBD of block kept at A. It will be mg, it will be n, and it is moving with v. So total force acting towards center is mg minus n, and we have and for centripetal force, what we do, whatever forces are acting toward the center, just write down those force and equate it with mv square by r. In this way we will get our centripetal force. So here n will be mg minus mv square by r, and suppose r is the radius we have given here, right? It will be the normal at point A. In a similar way, suppose if someone asks to find the what will be the normal at point B. So here also we have to just draw the FBD at B. What are the forces acting will be mg, and some normal will be acting in this way, and it has velocity. So what is the net force which is acting towards the center at point B? So at point B, the net force acting is nb minus mg equal to nv. This is the net force which is acting towards the center, and we have to equate this net force with mv square by r. So here what will be our nb? It will be mv square by r plus mg. This will be our nb at point this, right? So we have to complete centripetal. Now let's see the concept of simple and conical pendulum also. So in simple pendulum, what we have observed, the ball moves like this, right? This is a simple pendulum. So in this simple pendulum, what happens ki particle moves from here. This is the mean position at this point 80, and suppose this one is given as theta, then it will be theta and mg cos the mg. So what will be 80 at extreme point? At this point 80 will be g sin theta, right? And at extreme point we get max value. V becomes maximum at this mean point. So this is our simple pendulum, and in simple pendulum motion basically occurs in a vertical circle. In simple pendulum motion basically occurs in a vertical circle like this. And let's see the concept of conical pendulum. So conical pendulum what happens कि ऐसे रहता है this way. Conical pendulum, this is our conical pendulum. For also one thing कि for simple pendulum we have time period basically given as L upon G, right? And how this conical pendulum rotate? It rotates in a horizontal circle like this. So basically in conical pendulum motion occurs in a horizontal circle. So in work, power and energy basically we have covered ki what are the vertical circle or horizontal circle, and we have conserved the energy at the bottommost point, uppermost point, and we have to find the various conditions regarding the velocity, what should be the maximum velocity at bottommost point in order to cover the complete circle, in order to complete blah blah blah. So that part is covered in work, power, energy. So here basically we have to find see how we can apply the concepts of circular motion in this kind of pendulum. So suppose this is our conical pendulum, and let's see one question on this. One thing you also remember ki seconds pendulum, seconds pendulum is nothing but a pendulum having time period 2 seconds. That is known as the second pendulum. One thing you should remember this. Now we have to suppose, let's do one thing at this centrifugal. What we can do, suppose we have given the L, this angle theta, this length L, and we have to find a particle of mass m is attached here. It is moving in a conical pendulum, means it is moving in a horizontal circle, and we have to find the t time period of this mass m. We have to find the time period of this mass m. So how we will do? So we just have to draw the FBD of this mass m. So how we will proceed here? We will see कि some mg is acting at this point, and here it is cos theta. So here t is acting, here t is theta, and here t. So when we will resolve tension along horizontal and vertical direction, we will find कि t cos theta, and here it is t sin theta. Okay, so it is moving in a horizontal circle. So here what is the force which is acting towards the center? It is nothing but the t sin theta, which is providing the centripetal acceleration in this case. So we can equate the t sin theta as mv square by r, or mr omega square, right? And just equate as t cos theta as mg. So when we will solve this these two equations, we will get as tan theta is equal to r omega square upon g. But here we have got r. So can you tell me what will be the r in this case? It is moving in a horizontal circle, so we have to find it. This is the r. So how we can find this r? This r will be nothing but this L sin theta. So what we have to find? We have to find the time period, right? So from here we can find omega as g tan theta upon r. R here is L sin theta, just please note down it. And we have to find the t, and t is nothing but 2 pi by omega, as we know. So what will be the time period? Just we have to put the value of omega here. So omega here will be r upon g tan theta. Just replace r with L sin theta and g sin theta upon cos theta. sin theta will get cancelled, and we will get time period as t is equal to 2 pi under root L cos theta upon g. So this was the question once asked in IIT. So you can see how we can easily solve this question just by applying the basics of physics. So now let's try to finish our portion which we have to cover today, and let's move on to our next topic, which is circular turnings on road. So circular turnings on road. So basically circular turnings means kya, suppose if someone is moving in this kind of road, we all must have traveled across this kind of path where we move along this kind of road. So this is our circular turn. So in order to pass from this turn, we should have some speed limit. If we will cross that limit, it might happen ki we will face some accident. So in order to avoid those kind of accidents, we have made some kind of restriction on those paths ki our speed or velocity should be within this limit or that. So first of all, let's see ki this one is a circular path, right? So in order to cover this circular path, there should be some centripetal force, right? So in order to get centripetal force, we can get that in various ways. For example, if road is made smooth, then we will get that centripetal force through friction. Here in that case, through friction also, if it might happen if friction is not there, then also we can get centripetal force. In that case, we will have to bank our roads, that is, we will have to tilt our road. So through banking of roads also we just have to incline our roads as a with angle theta with horizontal. So in that case also we will get some centripetal force. In later part we will see how which one will be the exact force which will be providing centripetal force to us. So through banking of roads also we can get centripetal force in order to cover this circular track. And through friction, it might happen ki friction and banking both are there in order to provide the necessary centripetal force through friction and banking. These are the three cases through which we can get the necessary centripetal force. Let's consider each case one by one. So in first case friction will provide us the centripetal force. So first of all, let's consider the case when friction is providing the centripetal force. So in that case, what will happen ki there is a circular turn. So what will be its natural tendency? So apart from friction, none other forces are acting at the body at this point, right? So if we will observe this our motion, then friction must be there in order to provide the necessary centripetal force, and in order to take a safe turns, that is कि बॉडी स्कीड न करे और या कुछ काइंड ऑफ एक्सीडेंट ना हो जाए, इसके लिए क्या होना चाहिए कि फ्रिक्शन मस्ट बी ग्रेटर देन और इक्वल टू सेंट्रीपिटल फोर्स, दैट इज mr ओमेगा स्क्वायर. or mv square by r. फ्रिक्शन मैक्सिमम क्या हो जाएगा, म्यू mg must be greater than mv square by r. R is the radius of curvature of this path. Suppose say mm will get cancelled out and we will get as mu g r under root. This will be our v. We should be less than this much. If we will get beyond this value, then friction will not be able to provide the necessary centripetal force and body will start to skid. And now let's say कि suppose friction is not there, then in that case through banking of roads we can provide the necessary centripetal force. What will happen in that case कि suppose we have inclined our road at angle theta, right? So in that case what will happen कि our body is moving like this. This is our road and body is moving like body is taking some, suppose this is our inclined road and body is moving along this as circular. So what will happen ki, let's draw the FBD at this point. What will happen ki mg will be at this point, mg cos theta, mg here n will act in this direction, mg will act in this direction, and friction is not there. So we have given, and this one is theta, so this one will also get theta, and this will become theta. So here n sin theta will act in this direction and n cos theta will act in this direction. So here we can see कि one component of normal is providing the necessary centripetal force in this case, and when we will equate this n sin theta with mv square by r and n cos theta by mg, what we will find कि just divide these two equation, then we can find tan theta is equal to v square upon rg. So in this case the maximum safe speed will be v equal to under root rg tan theta, right? And this theta is also known as the angle of banking. So this is the safest. If we will travel through this speed v equal to under root rg tan theta, then we can travel safely on that road. Now let's see कि what will happen when both banking as well as friction will be there. Let's suppose the third case of where banking as well as friction both are there, both are acting. So in that case, for maximum safe speed के लिए क्या होगा कि यहाँ पे कुछ बॉडी है, ठीक. So let's draw the FBD first of all. कि n will act in this direction, mg will in this direction. So most important thing is the direction of friction. What will be the direction of friction? So how can we decide the direction of friction? It might be in this direction also, in this direction also. So how we will decide ki in which direction friction will act? So suppose in this case we will have range of velocity from v minimum to v maximum. If we are moving within this range, then there would not be any issue. But if we will cross this extreme range, then there will be some problem. So suppose first of all we will have to find the maximum speed with which we can travel. So when we will travel with maximum speed, in that case what will be the tendency? Suppose we are turning with very maximum speed, maximum safe rest speed. So in that case our tendency will have to slip out, means our tendency will be to move along this direction. If we will move with maximum surface speed, then our tendency will be to get thrown away in this direction. So friction must act in this direction for maximum safest speed. So for Vmax, we are calculating it for Vmax. So now draw the FBD of rest is the FBD part. So mg is f. So here theta, here will be theta, here also will be. So what are the forces which are acting in towards the center? So the forces which are acting towards the center are n sine theta, this is n cos theta, this is n sine theta, plus fr cos theta, and we have to just equate these forces which are acting towards the center with the centripetal force. This one will be our first equation, and what will be our second equation? Second equation will be n cos theta fr plus fr sin theta. N cos theta will be equal to mg plus fr sin theta. These are the two equations, and we know fr is nothing but mu n. One thing you must remember कि friction is not mu mg always. You just remember friction as mu times normal force, and this normal force sometimes get equal to mg and sometimes doesn't get equal to mg. So just remember friction as mu times normal force, not mu mg. So here also in second equation n cos theta minus mu n sin theta equal to mg. So here when cos theta minus mu sin theta is equal to mg. So this is our second equation. Just put the, this is our third which we got from second equation, and when we will put this n in first equation, and when we will put this value of n in first equation, we will get the value of Vmax. So from 1 mu n cos theta is equal to mv square by r, and n just being sin theta plus mu cos theta is equal to mv square by r, and n is nothing but mg by cos theta minus mu sin theta, and sin theta plus mu cos theta equal to mv square by r. So will get cancelled out, and finally we will get, when we will arrange our equation, we will get something like this rg. Just we have to divide the each term with cos theta, then in that case we will get tan theta plus mu upon 1 minus mu tan theta. This is our maximum speed through which we can travel when we have both friction as well as banking. So similarly we will have to apply the same approach for V minimum. So for in case of V minimum, we just have to take care of the direction of friction, in which direction friction will act for maximum and minimum case respectively. So let's discuss for a case of V minimum. What should be the V minimum? Suppose the particle is here, and in case of V minimum, what should be that minimum value of V for which the body should not slip down? So in that case, the tendency of body, in case of V minimum, the tendency of body will be to slip in this direction. So friction should act in this direction to avoid the slipping, right? So and rest are same, and just we have to use the same concept which we have done for the case of Vmax. We have to just write the equation of we just have to draw the FBD here first of all, and we have to write the equation just as we have done in the previous case. Here we will have n sin theta, n cos theta, n sin theta plus this is the friction force theta, n sin theta. Here it will be Fr cos theta, and it is Fr sin theta in upward direction. So what are the forces which is acting towards the center in this case? These are n sin theta minus Fr cos theta are acting towards the direction mv square by r. And what are the forces in vertical direction? That is, these are the n cos theta plus Fr sin theta. It will be equal to mg. So, and we have to just equate through these three questions. We will get our V minimum value, and after solving you will get V minimum as Rg tan theta minus mu upon 1 plus mu tan theta. You just have to do the same approach as we have done for in the case of Vmax, and after solving finally we will get at this. So what should be the possible range? So we should be V minimum for Vmax. Within this limit we will have to move along the banked roads when we have both friction as well as banking. So these are the dynamics part of circular motion. And one more important thing you can note down ki death well, which we also call it as मौत का कुआं. So in death well, suppose there is a death well and it is a cylinder, and the person who shows a drama in death well, suppose he is moving with V. So for him, what is the force which is acting toward the center for him? That is normal. Here normal force is providing him the necessary centripetal force. And here friction is this one is the mu is the coefficient of friction between the man and this surface, and here friction will act in this direction, so that in order to avoid the slipping of man towards downward direction. So basically what will be the FBD of man in this case, right? And is as mv square by r, which will be equal to, and Fr will be equal to mg. And friction is, as we know, friction is mu times normal force, and here we are getting normal force as mv square by r. Just remember ki don't blindly use friction as mu mg everywhere. Just always remember ki friction is nothing but mu times the normal force, and apply here. So we will equate mg with mu mv square by r. Mm will get cancelled out, g r upon mu. This will be the v speed with which a person moves in a death well. So these were the portions from dynamics part of circular motion. So this was all about the dynamics part of circular motion. So till now we have covered all the kinematics as well as the dynamics part of circular motion. So let's recall the things which we have covered, the entire thing which we have covered in the lecture series of circular motion. So in circular motion we started our lecture from basic introduction, where we introduced you to the basic parameters of circular motion, We also saw how the basic parameters of motion like distance, displacement, velocity and speed varies in circular motion. So we introduced some basic parameters. We also told you the relationship between linear and angular variables. So for example, s equal to r theta. We also taught you the relation between the linear and angular parameters, that is L is equal to r theta, V equal to r omega and A equal to r alpha. These are the parameters which must be remembered in order to solve the problems of circular motion. And after that we discuss the topic of uniform circular motion and non-uniform circular motion. What is the basic difference between uniform circular motion and non-uniform circular motion. So here we saw कि uniform circular motion में टेंजेंशियल कंपोनेंट नहीं होती है, जबकि नॉन यूनिफॉर्म सर्कुलर मोशन में एक टेंजेंशियल कंपोनेंट आ जाती है, जिसकी वजह से ए नेट निकालना हम लोगों ने, उसकी ए नेट आ जाता है. तो इन यूनिफॉर्म सर्कुलर मोशन में हमारा ए नेट जो होता है वो सिर्फ ए रेडियल होता है, बट इन नॉन यूनिफॉर्म सर्कुलर मोशन में हमारा ए नेट जो हो जाता है वो ए नेट अंडर रूट ऑफ ए नेट स्क्वायर. ए नेट इज नथिंग बट द अंडर रूट ऑफ ए आर स्क्वायर प्लस ए टी स्क्वायर होता है. So after that we solved many problems based on those concepts. And after that we saw the concept of radius of curvature ki in most of the exams also these questions are generally asked to find the radius of curvature of this curve. They will give you the general curve, and so you can easily solve the problems based on those radius of curvature and relative angular velocity. That was the simple procedure which we have to apply in order to find the relative angular velocity between two bodies. And after that we will saw the dynamics portion of circular motion. In that dynamic portions we saw the basic introduction of centripetal and centrifugal force, and we applied the concepts of centripetal and centrifugal force in solving problems. So you must practice some more problems based on those concepts so that you can get mastery over those concepts. And finally we saw टर्निंग्स ऑफ रोड कि कैसे रोड पे कितने स्पीड से चले कि रोड पे मैक्सिमम कि सेफली वी कैन क्रॉस दो सर्कुलर टर्न्स, एंड इन वेरियस पॉसिबल केसेस की जिसमें कि हाउ वी कैन गेट द सेंट्रीपिटल फोर्सेस इन सर्कुलर टर्न्स. एंड फाइनली वी सी की डेथ वेल की जिसे मौत का कुआं भी बोलते हैं हम लोग, कि कैसे कितनी स्पीड से वो बंदा घूम रहा होता है जिसकी वजह से वो नीचे नहीं गिरता नीचे. So these were all about the circular motion. So hope you have liked the almost all portion of circular motion. So best of luck, thank you, and please don't forget to like, subscribe and share the video.